Hello, I'm Gal Sela, a PhD student in the Technion, and I'm going to present a typo in the definition of linearizability. The paper is a joint work with Maurice Herlihy and Erez Petrank. Linearizability is highly prevalent and used as the de facto correctness condition for concurrent objects. In this paper, we point out a typo in the definition of linearizability. The typo affects the treatment of pending invocations. It causes the definition to contradict intuition and breaks its local and non-blocking properties. We propose an amendment that corrects the definition and solves these problems. Informally, linearizability classifies concurrent executions as correct if operations on shared objects appear to take effect instantaneously during the operation execution time. For example, here we see an execution of two threads, A and B, on a register initialized to 0. The execution is linearizable if the operations appear to take effect during their execution time, for example, in the indicated moments. Due to a typo, the definition does not enforce pending invocations to appear to take effect after the invocation. For example, consider this execution on a register which is initialized to 0. We would expect that the write would occur only after it is invoked, and so then the execution would be incorrect, as the earlier read will not be able to return 1. But the current definition does not restrict the timing of the pending write and allows it to occur in any time, including before its invocation. If the write occurs like that, before the read, then the read may legally return 1, and this odd execution will be classified as correct, although intuitively it isn't. We would not want the presented execution to be classified as linearizable, as the read by A cannot return 1, because 1 wasn't written to the register beforehand. Our amendment enforces pending invocations, like the write here, to occur after the invocation as expected. This way, with the fix, the presented execution becomes not linearizable as expected. I have demonstrated here how the typo causes an odd execution to be classified as linearizable, but I have used an equivalent intuitive definition of linearizability by linearization points, and not the definition from the original linearizability paper. To understand the precise typo in the original definition of linearizability, we need to first recall this definition. So consider this concurrent history, H, that we analyzed in the beginning of the talk. Linearizability aims to classify whether it is correct. It does so by relating it to a sequential history S, like this one. Linearizability dictates the following requirements on S. First, S should be a sequential history, which means that its operations do not overlap. It should also be legal, which means it should satisfy the sequential specification of the object. In case of a register, a read must return the last written value. S should also be equivalent to the original history, meaning each thread should observe the same events in the same order in S as in the original history. For example, here, A sees the same read with the same result in H and S, and afterwards the same write, and B sees the same write in H and S. Finally, S is required to preserve the order of non-overlapping operations in the original history. For example, here, the write of 1 happens before the write of 2 in H, so it should appear before the write of 2 in S as well. So overall, H is linearizable if there exists a sequential legal history S that is equivalent to the original history and preserves its order of non-overlapping operations. As we saw, H in the example here is thus linearizable. So far, we ignored the treatment of pending invocations, namely invocations that do not have a response, like the writes here. Some of the pending invocations might have taken effect, while others have not. We would like S to include only the invocations that took effect and throw away pending invocations that didn't take effect. So, in fact, S is not required to be equivalent to H, but rather to a history which contains the complete operations of H plus the pending invocations that already took effect. To enforce this formally, we first form an extension h prime from h by adding responses only to the pending invocations that took effect. In the example here, the write of 1 must have taken effect because the read returns 1, so a response is added for the write of 1. The pending invocations that didn't take effect in h are left without responses in h prime, so that they are elided in a second stage, which produces a history named complete h prime. In the presented example, if the call to write 2 has not yet updated the register during h, then we would like to exclude it from S. To this end, we do not add a response for it in h prime, which makes it eliminated from complete h prime. Overall, we placed all operations that took effect in complete h prime, including those related to pending invocations. So we would like S to reflect the operations in complete h prime. We would expect the requirements from S to relate to complete h prime. But a typo in the third condition of the original definition refers to h instead of complete h prime. To fix the typo, this reference to h should be replaced with complete h prime. Let's analyze the implications of the typo. Note that pending invocations are not considered to be operations. We show in the full paper that even if pending invocations are considered to be operations, the definition with the typo is still incorrect. But for now, let's assume that pending invocations are not considered to be operations. Since the third condition refers only to operations of h, then the order preservation is not enforced on the pending invocations of h, which are again not considered as operations. Therefore, histories like the one you see here are classified as linearizable against intuition. H here is intuitively incorrect, since for the read to return 1, the write must take effect before it was even invoked. However, due to the typo, a linearization S may be constructed for this H as follows. First, we form H prime by adding a response to the write, which must be linearized. Complete H prime is the same as H prime in this case, since no pending invocations are left. We then construct S by reversing the order of the write and the read, so that the read will legally return 1 in S. This reversal is made possible by the typo, which makes the third condition require S to respect order only among complete operations of H, which is a vacuous requirement in our example. The problem is that S is not required to respect the order of linearized pending invocations of H, and this enables S to place the pending write before the read that originally completed before the write started. To fix the typo, the third condition should refer to operations in complete H prime. This way, S will have to respect the order of linearized pending invocations of H as well. In our example, with the fix, the write could not occur before the read, and H would become non-linearizable as expected. We show in the paper that the typo also makes linearizability not local and not non-blocking, and proves that the amendment resolves these issues as well. We stress that the original paper had the correct intention and the adequate intuitive discussion, and that this correct intuition was adequately adopted in subsequent work to produce correct papers. Moreover, it is possible to fix the definition with a single prime addition, making H H prime. However, the definition with the typo was replicated into subsequent papers, and it is incorrect. Our paper fixes this by providing a rigorous definition which can be properly copied and used. We believe it is important that the corrected definition without the typo appears in the literature, as linearizability is extremely important for concurrent algorithms. In addition to having a rigorous definition in writing, this fix becomes increasingly important with the evolvement of architectures with non-volatile main memory, since invocations interrupted by a crash are in the focus of their correctness proof. For more details, you are encouraged to read the PODC brief announcement, which contains the corrected definition and the short discussion, and also the full technical report on arXiv, which extends the discussion of the problems with the typo. Thank you.